Hello and welcome to my channel. My name is CrypticCreations, aka Novelty Engine, and in today's video we want to talk about my channel symbol. So let's get into it. My channel symbol comes from, believe it or not, a two-dimensional version of special relativity in which we posit that time is discrete and the passage of which can be described as a wave-like motion along a continuum of discrete two-dimensional chronons in a two-dimensional time field. You can learn more about my theory, more about my idea in other videos that I have posted. I just wanted to let the viewer be aware that this is where the shape comes from, the shape of the channel symbol. So here we see a little bit more of the theory and how a free body diagram extended not in space but in just a presumed two dimensions of time from the beginning can be constructed such that whenever we set the result equal to the known value for, or the known expression for Lorentz time dilation, we get an equality, t equals t. So they're the same, mathematically they're the same expression. However, they come from two different results. One from the assumption of substituting vt for x, giving you time on the sides of your triangle, as opposed to our method, which just cuts space out altogether and just assumes two dimensions of time. And in doing so, we get this result. And well, you can't really argue with the mathematics. All you can argue is that, well, this is either a purely mathematical result or it is some sort of a physical indicator, and then we, that being the case, or the possibility that that's the case, we look for ways to prove this theory. And again, you can learn more about that in the videos that I have posted on the topic, as well as future videos that we will make on the subject. Moving on, now we see a more explicit derivation of the shape, which we call the Novelty Engine. So the channel name, Novelty Engine, also the shape is called the Novelty Engine. So what is it? It is Novelty Engine's Novelty Engine. And the Chronon Schooner, which is the scaled overlay of the discrete chronons between reference frames overlaid onto the free body diagram, and it gives us a great geometric way to understand the physics. But whenever v increases and you start moving at relativistic speeds, delta t is going to grow, and at a certain speed, at around 86.6% the speed of light, which is √3/2c, we get this y symmetry, and it lends itself quite well to doodling, to an artistic rendering, and that's exactly what the Novelty Engine is. And furthermore, the remainder of this video is going to be about how to solve for the blue area at the top of the figure that we call area A. I came up with this question right after drawing the picture. In fact, it's the picture that's the cover of my manuscript for time equilibrium for this idea, but the scratch back my neck, but the solution did not come until earlier this year during the COVID hoax lockdown. And so I came up with a technique to solve for area A. And let's see how that might be done. Oh yeah, by the way, if I'm being proper like other math channels, they'll say, pause the video and see if you can solve for area A using the unit circle, radius equals 1. That's all you're given. That's all I was given, and that's all you have to assume, assuming that you have classical training in mathematics. And all right, so here's where we get into how to solve the problem. Welcome back or whatever. Like, did you solve the problem? Let me know down in the comments if you were able to do so. This is one technique. I'm obviously not saying it's the only technique, but it's the only technique that I was able to come up with. And so you get your lines, equations for your lines, and we're asking how big is area A? มันใหญ่แค่ไหน? That's Thai language. Because I'm a Thai English teacher in Thailand. And okay, so what you do next is you take those equations and you want to find the intersection point of the line with the circle, and you do that by setting them equal, solve for x, take that value of x and put it back in to y in the other equation, and you get your y out. All that is setting equations equal, solving for x with a quadratic equation. Then we can check that those points are correct, because since we're using the unit circle, they need to be the hypotenuse of the right triangle constructed by using the x-coordinate as the base leg and the y-coordinate as the y leg of a right triangle. You should get 1 as the hypotenuse, and in fact that's what we get. So those are correct. That answer is correct, and furthermore we can expand that answer and reveal that points A, B, C, and D have these x and y coordinate values respectively, minding the negatives in the respective quadrants. And what do we do after this? What do we do after we know the intersection points? What can we do with those points? Well, we can sit down and we can define various areas out of pi over 2, which is going to be the area of the top half of the unit circle. And basically right off the top we get these two, or not right off the top, but maybe the first equation is a little bit less obvious. The second one, pi over 2, is going to be equal to 2b plus c minus a. Now we're calling b the part that encompasses a. In other words, like b is not separate from a. B is a shape that covers a, such that if you added two b's together, you would have two a's in there as well, which is why whenever you want to figure out what the value of pi over 2 would be in terms of these shapes, you have to take 2b plus the equilateral c and then subtract 1a out of it, because you already have an a in there. However, since we don't know b or a, we can't really use that equation. We have to use this first equation here. This a is equal to 2 times, in parentheses, e minus d plus c. And what that is doing is what's depicted here in the graphics over on the right hand side. The 2 times e minus d is a negative value, and then it's exactly smaller in absolute value or absolute size or whatever by a. Okay, so in other words, c minus 2e minus d is a. All right, and we can use that to solve for the value of a. Why? Because the skinny leg e, if we use not the approximation, or not an approximation of it, but rather the exact value, which we get from integrating over the intersection, from the intersection to the y-axis, or y-intercept of the circle, that's what we do. So we do that, we set up the integral. We're actually going to integrate from 0 up to point A's x-intercept point, or x-coordinate point, however you say it, and we let alpha equal it just because it's a lot to write out. And there's the answer, blah blah blah, with with all the alphas in there, 1/2 sine inverse of alpha plus alpha times square root of 1 minus alpha squared. You plug all that in, you get this little tiny area, area A. Once you have that, and you take your 2 times e minus d plus c, you're essentially ready to solve for the value of A. But before you can do it, you obviously have to know the equilateral area C is root 3 over 4. That's easy to calculate. And then D, the area for D comes from constructing a right triangle there. And you have to get the, well, you use whatever, like 1/2 base times height. But what's the height and what's the base? The height is the y-intercept and or y-coordinate, sorry if I'm misspeaking, but I hope it's clear, and the or clear enough. But the x, the base leg of the triangle that you want to construct in order to calculate the value of D, the area of D, is you need to add 1/2 to the value of the x coordinate, and that'll give you the base leg. You got your height, and then you just boom use the equation for area of a triangle. And then so you get it all, you calculate it, and we get A is equal to 0.0102 approximately. Now in order to check that, like what's going on this page, well, we're trying to show that you can check it by coming over here and seeing that E, the vertical rectangle integrated true area, plus pi over 4, which is half of pi over 2, obviously, that's going to be the area of the circle in the first quadrant. If you add them together, it's going to be equal to B plus D. And notice that this equation does not use A, so we can calculate B without using A. That's what's happening in the middle. And then once we get B, then we can turn around. Now that we have the values of A and B, now we can use 2B plus C minus A is equal to pi over 2 in order to calculate the value of pi over 2 and show that it is, in fact, what it should be. And that's what we do on, that's what we are showing on this slide. That's how you can confirm that this is the correct answer. Furthermore, we can be sure that the area we have calculated is the correct answer because of squeezing we can give an underestimate and an overestimate of the correct value, and we do so by taking a 1/16 of a 1/16 of the largest equilateral triangle, the big one that's the main overlay over the circle, a leg that is 1/256th of the original side length. Construct an equilateral with that, and that gives you the red triangle at the bottom that's just on top of my head. Above that one, the yellow, that's an arc sweep over 60 degrees for the same leg, for the same little 1/256th of a unit. And then the green, that's the renormalizing of it. That's where you get the area of, or excuse me, the leg. That's where you take it from the intersection point, and you take your triangle D, and what you want to do is calculate the hypotenuse of triangle D, and then subtract I think 1 from it. So the third one down, that root 3 over 4 times in parentheses square root of 7 plus root 13 over 8 minus 1 squared, that root term minus 1, that's the hypotenuse of D minus 1, giving you the length of that little leg that you want to use, and then just plugging it into the area formula. And then finally, area A is going to be bigger than that, but smaller than an arc sweep of the true intersection point, which will give you an area larger than area A. And that's essentially how you can prove it. You can also show that if you divided up this circle into square units on a grid and they were all 1/10 on a side, you would be able to fit 314.15 of them, right? So, and here you see pi over a is 307, and that is consistent because because 1/10 is as a decimal 0.01, and area A is 0.0102 and some change. And you can just see, like, if you were to put this up on a grid, I don't have the right slide on it, but you can see that it at least appears to be clear that that a 1/10 square unit is slightly smaller than area A. Okay, so so as not to beat a dead horse now, I think we have proven the point. This is how I solved the problem. This is my channel symbol. I hope you enjoyed this video. Here's the last slide. Any remaining comments I may have must be said now. Please subscribe to the channel for more content like this. If you like it, please feel free to like and comment and share, and I will see you again in the next video. Thank you.